Welcome back, everyone. Today, we're hitting a massive milestone in our journey. It's day 13 of our System Design Explainer series, and we're tackling the absolute holy grail of back-end performance, caching. If you've ever built an app that felt, just a little bit sluggish, or if you've ever wondered how the tech giants managed to serve up data to millions of users in the literal blink of an eye, well, you are in exactly the right place. Let's kick things off with a question that's probably haunted you at some point. Why do some apps load instantly while others just leave you staring at a spinning wheel? Honestly, the bottleneck is almost always data retrieval. Fetching data from a traditional database just takes time. And in the tech world, the stakes are unbelievably high. Amazon famously found that just 100 milliseconds of latency cost them 1% in sales. Think about that. Traditional databases are heavy, they require a lot of processing, and they can be pretty slow. So to understand how we fix this, I want you to start thinking about our system architecture not just as a bunch of servers, but as a highly efficient high-end restaurant kitchen. We'll get into exactly how that metaphor works in just a second. Okay, let's dive into this. First, we'll cover why we need caching. Then, enter Redis. Number 3, core caching strategies. 4, TTL and cache invalidation. 5, surviving a cache stampede. And finally, putting it into practice. All right, section 1, why we need caching. Listen, when you're designing backend architecture, you are operating in a high-stakes environment where every single millisecond counts. Picture your main database as the massive walk-in freezer at the back of a super busy restaurant. It holds absolutely everything you could possibly need, right? But it's all the way in the back. Walking back there, digging around for your ingredients, and hauling them back to the cooking station is just a slow process. Now, consider the cache. The cache is the chef's countertop. It doesn't hold everything. There's obviously no room for that, but it holds exactly what the chef is cooking right now. Reaching for an ingredient on the countertop is basically instantaneous. By moving our frequently requested data to the cache, we completely bypass that long, slow trip to the walk-in freezer. Moving on to section 2, enter Redis. So how do we actually build this high-speed countertop? Well, the undisputed heavyweight champion in this space is Redis. It's an open-source, in-memory data store used primarily as a blazing fast cache to speed up applications. And the absolute magic word here is in-memory. Unlike a traditional database that has to write to a physical hard drive or an SSD, Redis stores data directly in the RAM. And because RAM is just orders of magnitude faster than disk storage, Redis serves up data with sub-millisecond latency. It truly is the ultimate chef's countertop. Section 3, core caching strategies. Okay, we need to establish the operational rules of our kitchen, so we know exactly how our app, which is acting as our chef here, is going to move ingredients back and forth between the countertop and the freezer. Let's look at the most common strategy, which is called cache aside. First, the application checks the cache for the requested data. If it's not there, a situation we call a cache miss, the app moves to step 2 and fetches the data directly from the main database. Crucially, in step 3, the app writes that newly fetched data into the cache so it's ready to go for next time, and then finally returns the data to the user. So in this strategy, the cache sits aside the database, and your application code is in total control of the entire loading process. Now, what's really interesting about this next setup is how the flow fundamentally shifts when we need to save new data. This is the write-through strategy. Here, when the app has new data, it writes it directly to the cache first. But before it considers the job done, the cache immediately writes that data straight through to the main database synchronously. Only when both spots are successfully updated is success confirmed to the user. Why do it this way? Because it guarantees perfect consistency. The countertop and the freezer will always perfectly match. But, what if you literally just care about pure, raw speed above everything else? That brings us to write back. In this setup, the application writes data to the cache and instantly confirms success to the user. Boom. It is incredibly fast. Instead of waiting on the slow, heavy database, the cache asynchronously writes that data to the database later on in the background. The catch here is the risk. If the cache server happens to crash before that background asynchronous save actually happens, that data is permanently lost. So bringing it all together, when we weigh these strategies against each other side by side, clear trade-offs start to emerge across speed, data safety, and complexity. Cache aside is going to be your go-to for read-heavy apps. Write-through offers maximum data safety at the cost of just a little bit of write speed. And write-back gives you top-tier speed, but comes with a very real risk of data loss. Choosing the right strategy really just depends entirely on what your specific system values most. Which takes us to Section 4, TTL and Cache Invalidation. Choosing your caching strategy is vital, for sure, but what happens when the ingredients left sitting on the counter start to go bad? That's where TTL, or time to live, comes in. It's the exact lifespan or expiration timer assigned to a piece of cached data before it gets automatically deleted. Think of it as a built-in expiration date stamped onto every single piece of data in Redis. When the timer runs out, the data just vanishes. This forces the system to go back to the database and fetch fresh data the next time a user asks for it. To put that into perspective, at any given time, a large chunk of your cache data, usually around 75%, is fresh and perfectly usable. As time ticks down, a portion is getting closer to expiration, and eventually, that 5% slice hits its TTL limit and gets flushed out. Setting the correct TTL is a massive balancing act, right? Too long, and your users end up looking at stale, outdated information. Too short, and you're constantly hitting the database anyway, which kind of defeats the whole purpose of having a cache in the first place. But here's the catch. Sometimes we simply cannot sit around waiting for that timer to hit 0. What if a user updates their password or their profile picture? We want that change to be reflected instantly. This requires cache invalidation. This is the process of proactively removing or updating stale data in the cache before its TTL naturally expires. If the underlying database changes, your code has to step in and manually trigger a cache invalidation, so absolutely no one is served old data. All right, brace yourselves from Section 5, Surviving a Cache Stampede. Picture this. It's our restaurant kitchen during the peak Friday night dinner rush. Everything is moving perfectly, until suddenly, the most popular ingredient drops off the counter, and the entire kitchen staff rushes the walk-in freezer at the exact same second to get more. Total disaster. A cache stampede happens when a very high-demand piece of data suddenly hits its TTL and expires. In that exact fraction of a second, massive traffic hits simultaneously. And because the data is just gone, all of those requests miss the cache at once. Where do they go? They all hit the main database directly. The database gets completely overwhelmed by this sudden, massive spike in localized load, and it crashes. Just like that, your entire system goes down. Surviving this requires really careful planning, like adding slight random variations to your TTL times so things don't all expire simultaneously, keeping your system resilient even under peak load. Finally, Section 6, Putting it into practice. Okay, it is time to turn all this theory into actual code. To successfully add Redis to an app, just follow these 4 steps. First, don't just cache everything blindly. Actually profile your app and identify your absolute slowest database queries. Second, provision a Redis instance to act as your high-speed store. Third, look back at the trade-offs we just discussed and select the caching strategy that best fits your needs. And fourth, implement that cache logic, complete with careful TTLs and invalidation rules, straight into your code. And just like that, we've made it to the end of our Day 13 explainer. We've journeyed all the way from the slow, heavy walk-in freezer of traditional databases to the lightning-fast chef's countertop of Redis. So I'll leave you with this final thought as you look at your own code bases. Which caching strategy are you going to implement to rescue your slow application today? Thanks for joining me on this deep dive, and as always, keep building.